Go look at your refrigerator. Right now, there are probably 10 or 20 magnets stuck to it, holding up photos, grocery lists, postcards from places you barely remember visiting. Those magnets are just hanging there, defying gravity. But here is something you probably never stop to think about. Your fridge is not a magnet. Nothing inside it is generating a magnetic field, so if the fridge is not pulling those magnets toward it, why don't they just slide off and hit the floor? Your fridge door is made of steel, and steel is mostly iron. Now, iron has a very special property that separates it from almost every other material on Earth. It is what scientists call ferromagnetic. That word literally means iron magnetic, because iron was the first material humans ever noticed this property in. Ferromagnetic materials don't just respond to magnetic fields, they actively become magnets themselves when one gets close. But to understand why, we need to zoom in. Way in. Past the surface, past the molecules, all the way down to individual atoms. Every atom in a piece of iron has electrons orbiting its nucleus, and each of those electrons does something remarkable. It spins, not like a basketball on a fingertip, but in a quantum mechanical way that creates a tiny magnetic field. Every single electron is essentially a microscopic magnet. In most materials, these tiny magnets point in random directions and cancel each other out perfectly. Zero magnetism, but iron is different. In iron, neighboring atoms actually convince each other's electrons to spin the same way. This creates something called magnetic domains. Imagine a chunk of iron as a neighborhood where the houses are organized into blocks. Within each block, every house faces the same direction. That is a domain. Millions of atoms with their electron spins, all aligned, creating a region with a real magnetic field. But here is the catch. Each block faces a different direction from the next one. One domain points north, the one beside it points east, another points south. All those little magnetic forces pull in different directions, and they cancel out. The iron appears completely non-magnetic. Now you walk up to your fridge with a magnet in your hand. As the magnet gets close, its magnetic field reaches into the steel door, and the domains start to respond. The ones already pointing toward the magnet grow larger, swallowing up their neighbors. The ones pointing away shrink. It is like a crowd at a concert. At first, everyone is facing random directions, talking to each other. Then the band starts playing, and one by one, every person turns toward the stage. Within a fraction of a second, enough domains have aligned that the fridge door itself becomes magnetic. Right there, under the magnet, a small patch of your fridge is now generating its own magnetic field. It is reaching back toward the magnet, pulling it in. That is what is actually holding your grocery list up. Not just the magnet pulling on the fridge pulling on the magnet. Take the magnet away, and those domains slowly lose their alignment. The fridge goes back to being boring, non-magnetic steel. But try sticking a magnet to an aluminum can, or a copper pipe, or a gold ring. Nothing happens. You could bring the most powerful magnet ever built next to a block of aluminum, and it would just sit there, completely indifferent. That is because aluminum, copper, gold, silver, and the vast majority of elements are not ferromagnetic. Their atoms simply cannot coordinate their electron spins the way iron can. The magnetic fields of their electrons cancel out perfectly, and no external magnet can change that. Out of 118 known elements, only 4 are ferromagnetic at room temperature. 4. Iron, nickel, cobalt, and gadolinium. That is it. Everything else on the entire periodic table either ignores magnets completely or responds so weakly you would need laboratory instruments to even detect it. Steel works because it contains iron. Stainless steel is tricky though, because some types contain enough nickel and chromium to actually block the ferromagnetic effect. That is why some stainless steel fridges won't hold your magnets. The steel fought back and won. So why are these 4 elements so special? It comes down to a quantum mechanical effect called the exchange interaction. In normal materials, there is no particular reason for neighboring electron spins to align, but in iron, cobalt, nickel, and gadolinium, the atomic structure creates a situation where aligned spins are energetically favorable. The universe literally prefers them pointing the same way. and this force is not subtle. In iron, the exchange interaction is about 1,000 times stronger than the ordinary magnetic force between two electron magnets. It is overwhelmingly powerful. But even this powerful alignment has a weakness: heat. As you raise the temperature of a piece of iron, the atoms vibrate more and more violently. At 770 degrees Celsius, the vibrations become so intense that they completely overwhelm the exchange interaction. The domains shatter. The iron stops being ferromagnetic entirely. This critical temperature is called the Curie point, named after Pierre Curie. Every ferromagnetic material has one. Nickel loses its magnetism at just 358 degrees. Cobalt holds on until 1115. This is also why you should never drop a permanent magnet or smack it with a hammer. Each impact physically shakes the domains, knocking some of them out of alignment. Do it enough times and your magnet gets measurably weaker. It is the same principle as heating. You are adding energy that disrupts the careful alignment the domains worked so hard to maintain. Even just leaving a magnet sitting around for decades will cause it to slowly weaken as thermal vibrations gradually nudge domains out of place. So the next time you stick a magnet to your fridge, remember what is really happening. Your fridge was never magnetic. It is a block of steel with trillions of tiny magnetic domains, all pointing in random directions, perfectly canceling each other out. But the moment your magnet gets close, it reaches into the steel and convinces those domains to line up. The fridge becomes a magnet too, just for a moment, just in that one spot. It is not the magnet clinging to the fridge. The fridge is reaching back. If you like this video, check out one of these, and don't forget to subscribe.